Screen visuals.
Yes, sir. Properly visible, sir.
Okay, so everybody seen here the Ansys window that is known as the Ansys Workbench platform. Here is top side, the logo of Ansys, yellow and black color seen A, and here clearly seen that the workbench. Okay, so types of platform available uh, in Ansys software. So we discuss design assessment, eigenvalue buckling analysis. Here we can see that clearly electric, and here explicit dynamic analysis, and next one fluid flow. Which types of fluid flow? Blow molding, that is known as the polyflow, and fluid flow, this is the extrusion, polyflow, and fluid flow, CFX, fluid flow, fluent, fluid flow, polyflow, then harmonic response. This is the hydrodynamic diffraction. Then hydrodynamic response, IC engine fluent, IC engine fort, magnetostatic, modal analysis, and modal acoustics, random vibration, response spectrum, rigid dynamic, static acoustics, and static structural, steady state, thermal electric, throw flow, blade gun, topology optimization, transient structural, and transient thermal, turbo machinery. And this is the post type analysis. This is a different. All these types of analysis, numbers of platform available in Ansys. So now we can see here today static structural. So click on static structural. When you click on static structural, so you can see that static structural window, engineering data, geometry, model, setup, solution, and result. Okay, here by default set the static structural. We have to here piston analysis. Piston, so put up the piston analysis. Okay, so put up the piston analysis. So our analysis type is geometry name piston. Okay, so here engineering data. So engineering data, what is the means of the engineering data? Why require the engineering data? Because engineering data has a directory of material which is involved inside the Ansys software. Number of material we can see here. So click on the engineering data. When click on engineering data, so we clear seen that material structural steel. Every Ansys software by default material is selected structural steel. Okay, when you do any analysis, suppose that here numbers of material are available. Suppose that general material. Click on the general material. So in this directory, aluminum alloy. So we can see here bottom and the mechanical property aluminum alloy already involved inserted here already in this directory available. Okay, concrete. So concrete property density 2300 kg per meter cube. Okay, here we can see that the unit system. So we can change here your unit system, meter, which types of unit system. Mostly SI unit system we considered here. Okay, then these numbers of material: copper alloy, FR, gray cast iron, magnesium alloy, polystyrene, and silicon, stainless steel. Okay, and here some additive manufacturing material. In this directory, all material available, maximum numbers of material available in this directory. Suppose that this is the additive manufacturing. So you have done the additive manufacturing analysis. So only uh, 4 material are available, which is belong to the additive manufacturing material: stainless steel, then inconel and inconel 718, and yeah, this material is TI6A titanium alloy. Okay, Then click on the composite material. So composite material S class, E class, carbon fiber available here. This is the carbon fibers grade, carbon fiber 230 and carbon fiber 290, carbon fiber 395, E class material. These materials, all material fibers material property available here. Okay, this is all material property available. Next, different material we selected. Suppose that is piston material, we take the aluminum alloy. Okay, piston material, we take the aluminum alloy. So go to the aluminum, click on the aluminum alloy. Here we take the piston aluminum alloy or steel. Okay, and the piston make the steel, structural steel by default already said. Then go to the written project. So we go to the written project, click on the geometry, then right click on the geometry. So these, when you click on the geometry, right click, so these options will be open: new space clamp geometry, new design modular geometry, import geometry. So we go to the import geometry. Import geometry want to take the your model accurate importing place. So we find out our model. This is our model. Click on the model. So to right tick here, click. Okay, so click on the model. When you click on the model, when you click on the model, so here bottom you can see that the starting mechanical. Bottom we clearly seen that the starting mechanical. So we want to the wait here, and another window will be open. Another window will be open here only A. Here when the another window is will open here, so M. Okay, red color M logo will be show here. Our model will be import from desktop to, so our model open. This model clear shown. Yes, sir. Model
Yes, sir, it is visible.
model so
Yes, sir, it is visible. It is visible.
okay, okay. Okay. So this is the piston. Okay, this is the piston model. This model make on the solid software. So this model make on the solid software, and we save this file, stuff file. Okay, so here we save the stuff file, our model piston. Then this the upper head. This is the crown of the piston, and here the connecting rod. Place. Okay, so we find out the here the geometry, materials, massing, static, structural, and this all step here clearly seen that the pistons. So piston is structural steel. Suppose that we